Without further ado, a little bit of introduction about myself. I'm currently living in Indonesia, working as a fraud analyst in a company called Gojek. I'm spending my time mostly reading, cooking, working, swimming, and I have a lot of projects going on, which is keeping me busy. And when lockdown ends, I will go to a faraway hilly area and spend a week. Let's get started. So what really is big data and statistics? First of all, big data is not anything fancy. It's large volume of information, and this information can be about anything. On the left side of the slide, you can see the link for the exercises, which I have been sharing on the chat. If you have not been able to access it, just go from the slide. And big data analytics means you want to understand examine the information that is being presented in your big data, right? So please interject me when you have questions, but write it on the chat instead of saying it, because that will be easier. So first, let's get started. In order to understand any sort of big data, the first thing that you want to do is find out the descriptive statistics. What does descriptive statistics means? It means you want to characterize your data set, and some of the primary characterization of any data set is the average value of the data set, the median, which means the value that falls right in the middle of the ordered data set. So if you have a list of let's say the age of people in this group, then you order it and then find the age that is right in the middle. Mode is the value that occurs the highest number of time in the data set. So for example, in terms of the age of the people in this group, if most people are 30, then the mode is 30. So these are the primary descriptive stats that is used across the board for any big data analysis. These are the primary thing that you use to characterize a data set. The next thing that is important to understand is that in your data set, you can have different kinds of distribution. So what distribution means is how the data is occupying the space. So if you think that the space is the screen, then how does each data point fall onto the screen? And usually these distributions are called frequency distributions, which means that how many times is each instance showing up in the data set. So there are many kinds of distribution. As you can see here, there's uniform distribution, Bernoulli distribution, binomial, geometric, Poisson, exponential, log normal, etc. But for the interest of our course, we will only look at these three: uniform distribution, exponential, and normal distribution. So what is uniform distribution? Uniform distribution means that, so as I said, any data set is basically a list of a lot of information, right? So in that list, if the current data point is exactly the same as the previous data point, that means your distribution is uniform. As an example, let's say you are playing cards, and the probability, there are 52 cards in a deck, right? So the probability of drawing one card is 1 out of 52. And regardless of which card you draw, and at whatever point of time you draw, if the deck is full, then the probability is always 1 over 52. So now let's say I create a data set where each cell or each data point is the probability of drawing a card. So that means you can fill up the data set by drawing different cards every time. And every time you draw the card, you put the probability of drawing that card. So that means all the data points in that set is 1 over 52, which means it's a uniform distribution. Next thing is normal distribution. What normal distribution is, that in a normal distribution, all data points center around the average. So if you look at the curve here, this is the height of women and men. As you can see that in this, there is a highest point. Machkhane is the highest, and that's the mean. That's the mean, which is the average of height of women. And all other data points are actually kind of going towards the average. That means every data point is centered around the average. For men also, it's the same. So you have a mean, and there is an equal number of, almost equal number of data set on the left of the mean and the right of the mean. What does this mean in real life? Let's say the average height of women is 162 centimeter. This means that a lot of women will have a height of 162 centimeter, but the number of women who have who are shorter than 162, and the number of women who are taller than 162 are about the same in number in the world. So that is normal distribution. And lastly, exponential distribution. In exponential distribution, your current data point is a multiple of the next data point. Or let's put it this way, the next data point is the multiple of the current data point. And in an exponential distribution, the multiplication factor will be the same. So that sounds like it's a mouthful, but look at this.